So today's our topic or webinar session topic is how to use data science to solve a real world problems. Okay, so data science and machine learning and artificial intelligence all are currently trending topics. You all know, right? The exact topic, how to solve and all. I just wanted to give you or give. I just wanted to provide some motivation towards what is data science and why we need a data science concepts and all. Okay, so this is what our agenda. So I'm just trying to provide some intuition regarding why we need a data science and what is the data science and what are the steps directly involved to solve a real world problems using some data science techniques and approaches, and what kind of use cases are available or what are the real time examples and applications are available, that and all are we are going to cover in this today's session. I hope you all know what is data science. And why we need a data science. That is what the main question, right? So the main exact what purpose of using data science approaches, we all know the data science has becoming increasingly important, and this is popular, no? The popular trending word, the data science, right? So which is very, very popular due to its ability to do some we can do some task with the power of data. Yes, we all know data is a current oil, right? So with the help of data, huge amount of data, we can able to get some informations or we can able to take some decisions and all. That's why we all are eager to learn the data science concept, and which will provide you some valuable insights, and we can able to solve some complex problems as well, across not only with respect to specific domain, across various domains. This data science concept or data science approach is applicable. This approach can be applicable in any kind of domain, like healthcare sector, or recommendations, or e-commerce websites. Okay, so this would be applicable for different or multiple domains. So these are the most important, how do you say, most important point why we need a data science. Okay, so the first thing is data sciences comes under the we are rely on with the datas, right? With the help of large amount of data, if you have large amount of data with respect to some particular domain, from that data, what kind of task I can do, that is what your objective here. Okay, so the first what need or necessity is we can extract insights from the data. Okay, so from the available data, insights in the sense from the given data, how do you interpret something? Okay, is there any way to interpret, or is there any way to take some decisions to improve my to improve my profit and all, for example. Okay, so in order to achieve such kind of objective, I can I can do that using some data science approaches. The first need is we can extract the insights from the data, as well as the second step, I mean, in today's digital age, we have amount of large, enormous amount of data, right? Daily, with the help of some Facebook or Twitter and all, we, I mean, huge amount of data are generated daily. So the data science enables organization to extract valuable insights from this particular data or raw data. Okay, so allowing them to make data-driven decisions and optimize their operations. That is the main objective. And the second most important point is business intelligence and decision making. Okay, so we have some huge amount of data. From that data, if you are able to interpret something, okay, if you are able to interpret something, if you are able to identify something, based on that findings, I can take some decisions. Okay, so that is called as business intelligence. This decision making will help you to improve your business, right? Business trends and all. So that is called as business intelligence and decision making. So data science provides business with the tools to analyze. For business BI, for business analysis or intelligence, we have lot of tool, right? in order to interpret the data, in order to take some decisions and all, we have lot of currently we have lot of tools. Using Tableau or using Power BI, we can take some insights, we can derive some insights from the data. So for taking some decision and to improve my business and to analyze the current trend as well, we need a data science approach. Okay. And the third need is we can able to do some predictive analytics as well. That is, a data science enables predicting modeling. What is mean by predicting? You are trying to predict something, right? Which helps the forecast. You are trying to forecast the future trends and outcomes. If I have this kind of historical data, then what would be the expecting outcome or expecting output for next 5 years? That kind of future forecasting can be done using some data science approaches or steps. Okay. And the fourth point is personalization and customer experience. Okay. So if you have some raw data about e-commerce websites and all, by analyzing the customer informations, by analyzing the customer data, your data science technique or data science approach will allows the business to offer personalized experience. That is recommendation, right? If you if you entered into the e-commerce websites like Amazon or Flipkart, they will recommend some what collaborative product as well. They will recommend some new product as well. Yes, if you buy a particular mobile phone, then along with your mobile phone you can also buy that combo, the combo offer. You would have received this kind of combo offers in your Amazon website or Flipkart and all, right? That kind of personalization and recommendation can be done using data science approaches by analyzing your customer data. Okay. So this leads to improve the customer satisfaction. If you are see, without searching anything, if you are providing, if your like e-commerce websites provide some recommendation, then it obviously the customer would get satisfied, no? So it will leads the it will improve the customer satisfaction, and it will increase the engagement in the websites like Amazon or Flipkart. So obviously the purchase trend will be increased. Okay. And the next thing is in healthcare sector as well as medical, in healthcare sector also, yeah, you can use some data science approaches. You can get some medical insights as well. Okay. So in healthcare, the data science plays a very, very important role in analyzing the patient data. And by after analyzing the patient historical information, you can able to predict the disease outbreaks. Okay. You can able to discover some drugs and all, as well as you can able to personalized do some personalized medicine. And you can create even you can create some chatbot related agent and all. Okay. So using your data science approaches. And the next thing is, in real time we can able to detect fraud detection. We can do some fraud detection and security, which is used to develop a fraud detection. Your data science is used to develop a fraud detection system that will help and identify the suspicious activity in a financial transaction, not only in the banking transaction. This will find some financial and suspicious transaction. Okay. Cyber security threats can be found, and insurance claim, you can predict some insurance claims. You can save the organizations from potential losses and all, right? And the last but not the least, the research and exploration. Data science enables the researchers to analyze and interpret the large data set, and it will lead you to find some new discoveries as well as new advancement across the scientific fields. So these are the most important point for the need of data science. Why we need to follow the data science steps, or why we need to follow data science techniques and all. So the next what the topic is about, what is data science? Okay. So in general, on conclusion or on summary, I can state that data science plays a vital role in driving innovations It can enhancing the efficiency of a particular prototype and providing some valuable insights across the industries or across different domain as well. It has it's an important tool for business researchers and policymakers in their own particular domain of data driven decision making, right? And even it supports some problem solving technique as well. So that is the main purpose of using data science approaches. What is data science? This would be your formal definition of data science. So data science is a deep study of the massive amount of data. Okay, if you're having a large amount of data, you're trying to analyze, you're trying to understand the data. Okay, that is your very first step in your data science concept. And data science is, it's not a domain specific approach. It is an interdisciplinary field which will allow you to extract knowledge from structured or unstructured data. Okay, in healthcare sector, if you are interested to find the disease prediction, like whether the patient's whether the patient is suffered by a cancer or not. Okay, so in such kind of prediction, for in order to help the clinicians, uh, uh, you can use some data science approach. Okay, so first I will tell you what are the steps you have to follow in data science. You can correlate the steps into the healthcare sector. Okay, structured data are, we have a formal pattern uh, what DBMS or table, the rows and columns, that and all are called as structured data, right? A formal pattern, right? But unstructured in the sense, in Facebook we can get datas from datas like images, we can get datas like videos, text data, everything we get, right, from the Facebook website. Yes or no? So that and all are comes under your unstructured data. Okay, so that is the difference between structured and unstructured data. So data science help you to discover hidden patterns. Even if you are having structured data or unstructured data, the data science approach will support both kind of data types, whether it could be a structured or unstructured, and it will help you to identify the hidden pattern. Hidden pattern in the sense, once you have understand your data, it will find the pattern associated with that particular raw data. From that identified pattern, you can take some information. That information is going to be called as interpretation or insight. Okay, from that insight you can take some decision. So data science enables you to translate a business problem into a research project, and then you can translate it back into a practical solution. Okay, so that is this is the formal way of defining your data science. And what are the steps I have to follow in a real world problem? Okay, how I can solve some real world problem use cases using data science approach. For that purpose, we have 7 important steps. You should follow 7 important steps. The first step would be you have to define the problem. The second one would be a data collection, data cleaning and pre-processing, exploratory data analysis, feature engineering, model building. We will discuss. Okay, that is either it could be a machine learning model or a deep learning model, and data visualization and storytelling to take for the end user. These are the most important steps you should follow to solve the real world problems in a data science field. Okay, so if I gave one problem statement or use cases, then what you have to do, you have to clearly understand the statement or problem statement, and then you have to come up with the proper objective from the problem statement. That is what your first step. Okay, that is defining the problem. You have to clearly define the problem you want to solve. That is what your objective, right? So from the given problem statement or use cases, read the use cases carefully or problem statement carefully, and understand what kind of solution I need. If you are able to identify that aspect, you are able to find that aspect, then that would be considered as your objective. Okay, for the given problem statement, the very first step is you have to identify the objective, and based on that objective you can achieve you can able to derive the solution using data analysis. So this is very, very important, very, very most important step in your data science while solving your real world use cases. It is essential to have a well-defined problem statement to guide your data science efforts effectively. Okay. So, and after identifying your data, a problem statement or objective, the next immediate step is you should collect the data. That is what your next step. Okay. That is identifying the data sources. You have to identify the data sources which are relevant to the problem, and that data you can get the data from different places, right? Like such as databases or Kaggle or APIs, spreadsheets or text files. It could be either in, it could be in any format. Even from web scraping also you can get some data. So ensure that the data you are going to collect it is accurate, complete and representative of the problem. You should collect the data with respect to your problem statement, with respect to your problem domain. Don't collect unnecessary informations. Okay. That is your second step. And third step would be data cleaning and pre-processing. So, data is often messy, no? So, and it may contain some missing values, or it may contain some outliers or errors and all. And the data cleaning process and pre-processing involves the handling of missing data. You can remove the duplicate values. You can normalize the values. If you have some numerical values or quantitative values in your data set, you should do some normalization technique, that is scaling. Okay. That is, you should maintain your data in a proper scaling format. For example, in your feature one, or feature one might be like weight of the particular person, and the second feature two would be your height of the particular person. So weight is I can represent the weight using kg, right? 20 kg, for example, 20 kg, and height would be 70 centimeter. So, okay. So here the unit scale varies, no? So in first feature you are using kilogram, but in the second feature you are using centimeter, right? So in order to match, or in order to do some scaling process, I can do a normalizing or standard scaling approaches. Okay. So you can also use some box plot to identify the outliers, and this step is crucial for ensuring the quality and reliability of your analysis. So this is very, very important step, data cleaning and pre-processing. And the fourth step would be exploratory data analysis, which involves visualizing and summarizing the data to gain some initial insights into a pattern. Data analysis in the sense, after cleaning your data and after doing some pre-processing technique, you are trying to understand your data. Okay. So that is called as exploratory analysis. What kind of analysis you can perform here? Like you can check the correlation, you can check the relationship between one feature with another feature, or as well you can check the relationship between the first feature with the target variable, how the particular feature how this particular feature is important with respect to finding or predicting the target and all. Okay. So that analysis could be done in your exploratory data analysis. And the next thing is feature engineering. So in many cases, even though we have many features like F1 to F100 even, okay, so even though you have many features, it is necessary to understand which feature is more important, and which feature will provide more information towards finding or predicting my target variable. That is very, very important, right? Identifying the best feature or important feature from the given data set. And if some features are more correlated, then what you have to do, you have to eliminate any one of the feature. That is also comes under feature engineering. This is also very, very important task. Okay. And you can do some mathematical approach, you can do some mathematical implementation, like f1 could be transformed into f1 squared. Okay. So this kind of feature transformation, data transformation is applicable in your feature engineering. technique. Okay, so feature engineering involves transforming the data into more meaningful feature. That's it. Even though you are having F1 to F100 features, you are using feature engineering technique. You are trying to convert your feature into a more meaningful feature. Okay, which will improve your model performance, which will provide more insights or interpretation towards your data. Okay, and then model building. So model building is nothing but either it depends on the problem. You will need to choose appropriate machine learning or statistical models. Okay, your first step would be defining the problem. Okay, so first understand the goals and objectives you want to achieve through the data analysis. Okay, so this is very important step, and you have to collect the data from multiple sources. It could be either from databases or APIs. And data cleaning and pre-processing is also very important and essential step in data science project. And you can do some exploratory data analysis and feature engineering, and then model building. So what is model building here? That is, the selection of right model is very important, meaning which depends on the problem statement. You have to choose the appropriate machine learning or statistical model. Okay, either it could be a machine learning model or statistical model. So this would range from the simple linear regression to complex deep learning algorithm. The model building ranges from simple linear regression to complex deep learning algorithm. Okay, so first, according to your problem statement, you can use any one of the machine learning algorithm or deep learning algorithm or statistical method. Okay, so just consider the nature of your data, and then based on the specific problem requirement, you have to make a best choice, correct choice. That is your model building. Okay, so under model building, this is what your very first step, right? So under model building, you have to select the best model with respect to the problem statement, with respect to the given requirement. And then the next immediate step is you have to train your model. Yes, you have to train your model, right? In machine learning, this would be the most important phase. We need to train the model, then only we can able to evaluate my model performance. Okay, for that purpose, if you have a data set, I mean cleaned data set or pre-processed after performing your feature engineering and all, this could be considered as pre-processed. Okay, this would be considered as pre-processed data. After once you have received this kind of pre-processed data, then you can start building your model. For that purpose, your data set is going to be splitted into two parts. One is test and another one is train, and another one is test. Okay, this is training, and another data set is test. In general, this 100% data set would be divided into, in general, for 70% of the data is going to be allotted for training, as well as 30% of the data is going to be allotted for test data set. Yes, so if more number of data have been provided for training purpose, then you will get a more accurate result. That is the main objective or intention of splitting this, using this kind of split. Either it could be 70-30 is the globally acceptable splitting technique, otherwise 80-20. Okay, and then after splitting your data set, what you can do with the help of this 70% of data. Okay, with the help of this, if this is your data set, this 70% is under your training data set. Okay, in this training data set, I'm just passing this training data set into my model, and my model will learn these informations or datas, features available in my training data set, and then it will predict the result. Okay, and then after training your model, then the next immediate step is you can evaluate your model. How do you evaluate your model? This 30% we have test data, right? This is unseen data. This is often called as unseen data, meaning which your model doesn't know the what output variable here. Okay, the target variable here. Okay, your model doesn't, we are not passing the target to my model. I'm just passing the input features alone, f1 to f100. This would be my predicting variable predictor, that is y. Okay, this is what I'm trying to predict. But in training phase, you have passed both the input feature as well as output label. Okay, so based on that learning experience, your model will try to find the outcome for the unseen data. That is what your model evaluation. So for under model evaluation, we will have lot of performance evaluation metrics are there. If you're using it, again, it depends on your problem statement. If your problem statement is, if you are going to predict some house prediction, price of the house, or if you are trying to predict some insurance cost amount or car cost, and or mobile price prediction and all, okay, that and all comes under your regression technique, right? So for that, in order to identify the model evaluation, we have lot of performance metrics like RMSE, root mean squared error. Okay, so you can find the error values, and if error is low, then I can state that my model is working fine, right? And for classification kind of problem, what you can do, you can compute the like confusion matrix. So using that, we can compute the F1 score. If F1 score is high, I can state that my model is better model, right? And you can do some model interpretation as well. You are trying to understand the model's decision and output. Okay, so if output is crucial for gaining actionable insights, right? You are trying to understand your model decision. That's it. That is called as model interpretation. Techniques like feature importance analysis, which feature is very, very important to finding the target variable. That kind of analysis would be comes under your model interpretation. Okay, so this is your model building, step 7. So under model building, we can take any kind of algorithm, like it could be either a machine learning approach, or it could be either deep learning approach, or it could be a statistical approach as well. Okay, so the thing is, see, you have to identify the best algorithm based on your problem requirement. Okay, so here I have stated some possible questions. So is this A or B? Okay, if your problem statement is, you have to identify, or you have to categorize whether this particular item or category is uh, type A or type B. Okay, for this kind of problem statement, you can use a classification related algorithm. Okay, whether a type A or B, male or female, disease or normal, or what kind of image classification related problem, or disease classification related problem. Okay, for all kind of classification, if your problem statement is related with respect to classification, then you can go ahead with your classification algorithm. You would have at least you would have stated minimum of 3 algorithm, right? Like KNN, SVM, or random forest, or decision tree. For the sake of explanation, I restricted with only 3 algorithm. And see, which one would be the best thing? How do you evaluate this? See, this is what your problem statement. So I thoroughly understand my problem statement. I concluded that for this kind of problem statement, I need some classification related algorithm. And I know I have 3 kind of classification algorithm, like KN, nearest neighbor, and SVM, decision tree and all. Okay, so how do you evaluate which one is the best algorithm with respect to my problem statement? Any idea? Yes, logistic regression is also one of the classification algorithm. Yes, Malik, according to your accuracy score. So for that, what you have to do, you have to train your model for classification. KNN approach first, and then you have to train your model for SVM model, and then you need to train your model using decision tree classifier. And then the next immediate step would be find the accuracy or FN score, find the accuracy or FN score for KNN, SVM, and then decision tree. So based on the highest accuracy value, I can pick and I can interpret this particular. For example, if decision tree provides highest accuracy, then what I can state, this decision tree would provide me the highest accuracy. So I would prefer decision tree for this kind of problem statement. Okay, it is not necessary that your decision tree will always provide you the highest accuracy for all such kind of problem statement. Again, it depends on your problem statement and domain as well as the problem requirement. Okay, clear? That is what we discussed here. Selection of right model is very, very important. So you have to train your model for all such kind of algorithms and evaluate your model, and then model interpretation is very, very important. Okay, is this different? Is this different? For this kind of question, I can state it's an anomaly detection algorithm, right? You have to use again some kind of classification related algorithm. Okay, anomaly, it's an anomaly detection algorithm. And then how much or how many? What would be the house price? See, in the first category, I have, yes, regression, right? In the first category, I have different category, right? Like the what type 1, type 2, type 3. If I'm interested to predict whether with the help of the given dependent variable, okay, whether with the help of the given input variables, whether my target is going to be type 1 or type 2 or type 3. If you are interested to find this kind of approach, if your target variable is like this, then I can state that that would be your classification algorithm or classification problem. For example, if my Y output variable would be 2508 or 3251.008. So for this kind of approach, if you are interested to find whether for a given input variables x1, x2, x3, by analyzing these input variables x1, x2, x3, if you are interested to find your target variable like 2000 or 3251.08, then that would be comes under regression algorithm. Hope you understood, right? How much or how many comes under your regression kind of problem. Okay, so linear regression, polynomial regression, multiple linear regression, that and all comes under your regression algorithm. And how you are going to organize. Okay, in the previous cases, in the previous approaches, I know my target variable. Okay, so this is in the classification problem. I know my target variable is Y variable is, I'm interested to find whether this is going to be type 1, type 2 or type 3. In regression problem, I know the value and all, right? The real values. Okay, but in this clustering algorithm, these two types are comes under your supervised algorithm. Yes, because if you know input variable, along with the input variable, if you are able to identify the output variable, okay, if you are trying to pass the both input as well as output combination in your model building or model training, then that kind of approach is called as supervised learning algorithm. And I know only inputs x1, x2, x3, x4 till x100. I don't know the output, exact output, even for training data set also. That kind of approach is going to be called as unsupervised learning. Okay, so for unsupervised learning, we need a clustering algorithm. That is, K means clustering, based on the features and based on the characteristics of x1, x2 till if you have x100. Okay, based on these features, characteristics, I can group for row 1 to 100. For row 1 to 100s are a similar comes under similar pattern. I can categorize under this as cluster 1 or category 1. Okay, so in such way you are going to organize your data. You are trying to organize your information. That is called as clustering algorithm. And then the next important topic is what should I do next? Okay, that is called as reinforcement learning. So under model building in the sense what, once you have finalized or the important, the pre-processed data. Once you get pre-processed data, what you have to do? You have to train your model, right? That is what machine learning. The data science is a combination of all such important trending technologies, right? So we need, if you are going to see again, I am telling you that data science, the summary, the data science is nothing but what, it's a step-by-step process. It's a iterative process. Okay, like we have to follow all 7 or we have to follow all 9 or 10 steps, then only your data science project, you can tell that I'm just completing my data science project. Okay, so under this you have important step called model building. For model building, you can either use machine learning ML model as well as deep learning model. I'm just interested to introduce the ML model alone here. So once you get pre-processed data, this pre-processed data, for example, if you have 100 inputs, 100 rows in your data set, 100 rows in your pre-processed data, in this 100 instance, I'm just trying to split my data into two important parts, which is called as training as well as testing. Okay, for example, if I have 5 features, x1, x2, x3, x4 and x5, and this would be my prediction y. Okay, for example, this is yes or no. I'm interested to find whether my inputs, this is R1 to R, you have 100 rows, right? For training, I'm just using 70% of the data, and for testing, I'm interested to use 30% of the data. Okay, so for R1 to, it's actually here I have used the sequential data, but it will randomly select the data. Okay, R1 to R70, and then this information will be passed to the training model. Either it could be using KNN or random decision tree or SVM. For you have to analyze the performance metrics for all such algorithm, then you can pick any one of the algorithm as a best model. So this is for training, right? And for testing, you have not passed this Y. You have passed only x1, x2, x3, x4, x5, and you're interested to find the prediction that is called as Y prediction, and you just compare Y prediction as well as actual output, and then based on that you can compare your model. This is what your model building. And then the next step is about data visualization and storytelling. Okay, so data visualization in the sense, if you're you have to do a lot of analysis. Okay, if you have to do a lot of analysis, then only you can come to some conclusion. You can came some conclusion about your raw data. Okay, so even if you have done enough amount of, even if you have put a large amount of effort on data analysis, but it's very important to convey that information properly to the end user. That is very, very important, right? So conveying the that is communication is very, very important. For that purpose, data visualization, for data visualization, we have lot of tools, like you can use Tableau or you can use Power BI. Yes, and or in Python also we can have lot of visualization packages are available. Okay, like what, Matplotlib and Seaborn SNS. Okay, and even we have another Python library called for current trending web technology, or like for a modern web page development, I have Poca. Okay, so these are some Python related libraries. Using these libraries as well as using these tools, I can easily visualize the information. I can easily come up with some visualization. But the thing is, with the help of that visual, how you are going to communicate with the end user, who are your target audience, that is very, very important. According to your, first you have to narrow down your target audience, and you have to understand the requirement of your target audience, and based on that understanding, you can tell your stories using by creating some storyboards as well as by creating dashboard. Okay, this is what your next step, communicating the insights that you find from the data to a non-technical audience. Okay, you are not communicating your informations to the technical audience. You have to communicate to the end user. That is like end user in the sense, maybe CEO of your company. Okay, it is not necessary that your end user might be your technical audience. Okay, so you have to prepare your story, or you have to prepare your insights, or you have to interpret the information uh, for non-technical audience as well. Okay, that is the very, very important and important skills required for data scientist. Okay, there are many tools are available for storytelling. You can use Tableau or Power BI, which will help you in a building a better visualization. Yes. Okay, as if why we use a regression algorithm and what is the importance compared to other algorithm. See, for as if for regression algorithm, if your target variable is like this, like real numbers, okay, house price prediction, or mobile price prediction, car price prediction. Otherwise, some if you are interested to find the weight, of particular species, or if you are interested to find the length of particular species or plant leaf length or leaf width. Okay, for such kind of problem statement, you have to use regression problem, because regression problem is it's like a what we are interested to find the it's a mathematical related approach. Y is equal to mx plus c slope formula. Yes, so for such kind of real numbers, if you are interested to find the real numbers, if your y or output variable is real numbers, then I can use a regression problem. This slope formula will help you to find the real values. Hope you understood. Okay, but we cannot use regression formula. We cannot use regression formula for classification problem. You cannot use this for finding whether yes or no type problem. If your y variable, output variable is yes or no, you cannot use regression type of problem. Okay, regression type of algorithm. See, each and every algorithm will have their unique features as well as unique importance. The thing is, based on the problem statement, if I give two problem statement to you, find the price for the find the square feet for the given area, or just predict the wind speed. Okay, for such kind of problem statement, you can use regression. If you that's what I'm telling. In the very first step itself, from the problem statement or from the use case, you have to narrow down your objective, what you are trying to find. That is what very, very important. If you have identified your objective, then you can easily come up with what kind of algorithm is suitable. Okay, and dashboard it's a very, very huge concept, Ratnam. It comes under your data visualization topic, and I will give you one example, right, for dashboard. Yes, live IPL matches and all that and all comes under the same problem. See, this is called as dashboard preparation. See, using a Tableau tool or using a Power BI, you can able to design this kind of dashboard. If you see here, this is one graph, right? This could be considered as a one visualization, and this would be your another visualization, right? I can state that this is for graph 1 or visual 1. This is graph 2, graph 3, graph 4, or graph 5, 6, and 7. In this dashboard, that is a very different topic. We need to understand the problem statement, as well as we need to understand the solution, in which way they are getting this kind of graph and all. Then only I can state that whether this is strategic or dynamic. This is, I hope this is not a dynamic one, right? It's a strategic, I hope. Okay, we are not using any live any live trend and all. If this graph changes dynamically based on the information's current data and all, then that could be your dynamic dashboard. Yes. Hope you understood. See, this individual visual representation or individual graph could be derived using Tableau. You can get this kind of graph using Python libraries and all, right? And after that, in Tableau, you have another tool called that I mean, you have another important feature called dashboard. Okay. After creating this dashboard, uh, in the screen itself, whatever visuals you have created, like Excel sheet, okay, this is graph 1. If you are using graph 1 here for using feature 1 and feature 2, then you would get graph 1. And in graph 2 you have used feature 1 and target variable, and for graph 3 you have used feature 3 and your target variable. Okay, so you have derived, or you have come up with these 3 graphs. And after creating a new dashboard, you can directly pick or drag and drop this images into the dashboard. Then you can create this kind of dashboard. Okay, in a single page, you're telling you're going to provide more informations towards the end user. And the ninth step would be your deployment and monitoring. Okay, so once you have a model, once you have identified which model performs well, for example, if decision tree performs well, what you have to do, you have to deploy the decision tree model in a real world setting. That is what your step 9. Yes. And this may involve creating a web applications, monitoring. This deployment is nothing but you're creating a real world prototype, and monitoring in the sense whether my decision tree model works well for all such live data or not. That is called as monitoring. For that, you can integrate with the web applications in order to monitor your model. Okay, you can take automatic, you can automate the decision making process as well here, and regularly monitor the model performance to ensure its effectiveness over time. This is your 9th step. And 10th step would be a continuous improvement. See, data science is an iterative process, because we have in total we have 10 steps, right? So it's an iterative process. You just collect the feedback, monitor the result, continuously improve your model and solution based on the new data and changing requirement. This is what your continuous improvement. If you have completed all 10 steps, then you can state that I have completed one real world problem using data science. Okay, so these are some use cases you can implement, like social analytics and Facebook. You can improve the e-commerce experience. You can recommend the product, okay, for the customer. You can recommend the product, and you can optimize the rights, as well as you can increase the customer experience, and improve the searches. And you can also recommend some music as well. Okay, using using the data science approaches and steps. Okay, so anomaly detection, in the sense, it comes under either it could be you can detect fraud detection in the financial transaction, or disease detection, or crime detection. Okay, and automation and decision making, in the sense, credit card worthiness. Yeah, if you are interested to check the worthiness of credit, as well as background check and all, then you can take some automation and decision making. And for classification, whether the given email is important one or junk. And you can also forecast like stock or revenue, sales, customer retention and all. You can also find the pattern reduction, weather patterns. Okay, if day 1, day 2, day 3, if continuous consecutive 3 days are rainy, if weather condition for the continuous 3 consecutive days of weather is going to be rainy, then what would be your 4th day weather, the weather prediction based on the pattern? If R, then the 4th day it could be R, it would be R, right? Again, the most of 80 percentage, for example, I can say 80 percentage of the chances of for raining, right? So by observing the pattern, you could predict. or you can predict the weather prediction or financial market patterns also. You can recognize facial recognition is also one of the real world example, and voice recognition, text uh, in your mobile phone, in a keypad. If you are trying to type MA, automatically the madam will come, right? This kind of next word prediction, what you are trying to type, that kind of recognition, text recognition is comes under your recognition, one of the real world example, and you can do some recommendations as well. See, uh, here I'm just taking a simple example, like you all know Netflix, right? Here I'm just taking the Netflix data set. Okay, so here the problem definition, we have some data set about raw data about Netflix, like in the Netflix, how many TV shows are there, how many movies are there, how many live streaming informations are there. Such kind of informations are loaded into your Netflix data set. Okay, this is a rapidly expanding application which gains more popularity due to its shows as well as content. Yes or no? Yes. So in this analysis, we are trying to explore the data. We are trying to understand the data through EDA and storytelling, and we are trying to incorporate, or we are trying to interpret the content based recommendation system, and variety of we are trying to illustrate some variety of graphs and visuals to enhance the presentation for storytelling. Okay, so the very first step is problem identification. No, so what is problem definition here? I have only raw data, like my data will have only the what are the different types of shows, movie shows, or different types of movies are there currently running, and who is the director, and what is the genre, and that kind of information is available in my raw data. And from this raw data, it is my duty to understand the objective problem definition, right? So I will give some example how to come up with the problem statement. So the first problem statement would be, we can understand, the first objective is to understand the user preference, current trends. The first objective would be user preference. Yes or no? See, the first problem statement would be, you can identify the user preference. Yes or no? The customer preference, whether the customer provides more preference on movie show, or TV show or movies. Okay, you can understand the pattern, or you can understand the behavior of your customer based on their preference. That is your first objective. And the second objective would be, you can analyze the current trend, which shows watched which shows or which movie show watched more than 1,000 times, or in such a way you can identify the current trends, as well as you can optimize the platform's content offering to enhance the user experience. Yes, and as well as you can also provide some feedback to the customer, and you can get the ratings. You can also able to get the ratings. Based on the rating, you can categorize this movie is this particular show is top 5, comes under top 5, or it's not interested, this is failure case, this is failure budget project, and all that. And that kind of decision you can take, right? Predicting the user rating and recommending some personalized content. If you are interested in crime, if you are watching more than if you are frequently watching a crime related series or crime related movies, obviously your Netflix will recommend such kind of content, right? So that is, these all are comes under your problem definition. I have stated lot of problem statement. You can take any one of the problem statement according to the requirement. Okay, and then you can proceed further. And what is your second step? Data collection, right? For here, I'm just collecting the data like Netflix data set. Okay, which contains Netflix movies and TV shows, including some attributes like a title, genre, release year, rating, cast, director, and user ratings and all. Okay, these are some in features Features in the sense input features. Based on the input feature, what you are trying to predict. That is what your objective. Okay. And you can do some data cleaning. You can do some data exploratory. I'm not going to explain that part. This is that and all comes under your machine learning concept. Okay. So I'm just trying to give you how you can interpret the information. Okay. So just import the relevant libraries, Python libraries. I have imported NP, that is NumPy library, Pandas, Matplotlib, Seaborn, and Plotly, right? Okay, this is again, it's again repeated here. Please ignore it. And for NumPy is for linear algebra. Okay, if you want to do some linear algebra or a linear mathematical related concept, if you want to use, or if you want to convert some arrays, okay, so for that kind of task we need NumPy package. Okay, and then for Pandas will give you it will create the data set. It will convert your data set CSV file into data frame. Data frame is more structured way of data. Okay, and Matplotlib and Seaborn will help you to provide some visual representation. And the next thing is, if you have a CSV file, just simply mount your drive by clicking this button. You can mount your drive. Yeah, then you can run this cell. Okay, a drive is already mounted, right? And I have created one folder called GUVI webinar, and under this folder I have uploaded all relevant CSV files as well as my IPython notebook and all. If you have a direct CSV file, just click on this 3 dot and copy path, and you can directly provide Netflix overall, which is equal to pd.read CSV. I'm trying to read CSV file. Okay, you can in this quotation, within this double quotation. Okay, within this double quotes, you can paste. You can paste the link path. Okay, then you can convert your CSV into data frame. But I have Google Sheet here. It's not a CSV file. Okay, it's not a CSV file. So what I have to do for that purpose, I can use these 3 code snippet. First, create the sheet ID variable. Sheet ID, you need to know sheet ID and sheet name, and then you can get the sheet URL. How to get it? For sheet ID, sheet ID is nothing but this is what your Google Sheet, right? This is what your Google Sheet. Under, I mean, in this link, after D slash, you have this kind of informations. See, this is what your Google Sheet. If you find the name http://doc.google.com spreadsheet/D, after D, you can get some information here, some numbers, key values before edit. This is going to be considered as your sheet ID. Okay, just put the sheet ID, and sheet name is nothing but in this what is my sheet name? Netflix, right? This is what my sheet name, and just put the sheet name and execute this cell, and you just copy, I mean, you just use this code snippet to convert your Google Sheet into a CSV file. Okay, so just pass the parameter sheet ID, whatever sheet ID you have created so far, sheet ID and sheet name. Use these 2 input parameters. You just pass these parameter in order to format this Google Sheet into CSV format, and then execute this particular cell. You will get this kind of Google Sheet URL. Just copy the URL and pd.read CSV and paste it over here. Then this Google Sheet will be converted into data frame. Now I have created Netflix overall as one of the data frame here. Okay, and if I want to check what are the features or what are the columns are available in my data, for that purpose I can use head method, head function. This is what my created data frame, Netflix overall.head, which will provide you the first 5 informations, first 5 rows. Okay, you can also give tails. This will provide you the last 5 rows. Okay, after executing this, you will get this kind of output. Okay, this is what my data set. Here I have show ID, type, title, director, cast, country, date added, release year, rating, duration, listed in, description and all. Okay, and then I can how many informations are there, how many instances are there. For that purpose, for each and every row, how many informations, how many instances are there, for that I can simply use count method. Okay, Netflix underscore overall is my data frame name dot count method. If you call this count method, this will provide you the count. For show ID, you have 6234, and for description also 6234. This 6234 is nothing but 6234 instances or rows are there in your data set. Yes, and I'm just filtering, I'm just creating another data frame called Netflix shows, meaning which based on the show type. Here I have two types of shows. One is TV show and another one is movies. Okay, so based on the show type, I'm just creating two data frames. One is Netflix shows and another one is Netflix movies. So for that filtering process, I can use this kind of code snippet. This is what my original data frame variable Netflix underscore overall. Under this, I'm just considering type alone. If type is equal to TV show, just pick that row alone and create a new data frame called Netflix shows. This will give you only TV shows instances alone. Similarly, you can also create movies. Instead of shows, you have to provide movie. Okay, and I have created two more data frames using based on the type, whether it could be a movie or it could be a TV show. After that, I'm just analyzing the movies versus TV shows. That is, how many movies are there and how many TV shows are there. Okay, so for that, I can use this kind of visual representation using Seaborn. I'm just setting the style, our dark grid. This is what your grid structure. Okay, and I'm just using the count plot. What is the purpose of using count plot here is it will count the number of instances and accordingly it will create the bar plot. Okay, here x is equal to type, meaning which based on the type, I'm just counting. Movie is around above 4,000, as well as TV show is more than 1,000. It's nearly 1,700 or 800, right? So this is how you can visualize the data. This is how you can understand your data. And suppose if some producer wants to release some content, either it could be movie show or it could be a movie or it could be a TV show. So in which month is most preferable month? If producer asks you to identify the month or the most preferable or most favorable month, what you have to do as a data analysis? Okay, as a data analyst, you have to understand the data first. For that, what I have created here, see, in this data frame, I have dates, right? Release date, release year, I have release year, date added September 9, 2019. So based on this added information, date information, I can understand and I can interpret in which month more shows or more movies were released. So based on that, I can suggest the producer that okay, this and this month will be more suitable for you to release your movie or release your shows. Okay, so this is how you can analyze. For that purpose, what you have to do, in the Netflix shows, I have a date added. Okay, and based on that date added, I'm just splitting my dates with respect to year as well as month. Okay, if you see the data frame, here September 8, 2017, no, so I need to split this information by year as well as month. So that's why I used these two code snippet. I'm just converting, I'm just splitting using the x dot split operation. I'm just splitting the dates. Okay, so after that, I'm just taking the month order from January to December. This is what my order. Okay, I have to use this month order, and you can group year as well as month, in which year, in which month, how many shows were presented or how many shows were released. So that is what my interest, right? So using this line, you can group. After splitting this, you can group together, and then you can plot. See, by using these codes alone, it is not sufficient to explain to the end user. End user here is producer. No, it is not sufficient. So in order to incorporate or in order to communicate such information, we need some visual representation. Yes or no? For that purpose, I have created a plot. I am just creating the figure over here using these code snippet. After executing this content code snippet, I would receive Netflix content updates. Okay, that is from starting month January to December, from the starting year 2008 to 2020, how many contents or how many shows or movies were released. Here the color coding represents nothing but darker shade represents more number of contents were released or movies were released. Lighter shade will represent you the lesser number of movies or contents were released. Okay, so just analyze this image alone. Okay, and during 1929, during 1919, okay, just tell me, just consider this year alone. During 2019, in which month the producer can introduce the new content? And during which month? We have January, February, March, April. Don't forget, the dark shade will represent more contents were already there. More contents. Dark shade represent always more, which will give you more information, right? Compared to these colors, I can state that this light orange as well as this light orange, if producer asks you to provide 2 months, 2 favorable months, then I can pick this color, this orange as well as this orange, right? Only 2 months. If I restricted with only 2 months, as a data analysis, you can provide January and December, and except these 2 months, rest of all other months color coding is darker, right? Little bit darker, meaning which more contents were already included or released during that month. So you can preferably choose January or December, then you will get more profit. That kind of interpretation or communication needs to be provided to the end user, like producer, by the AI analysis, like data analyst or data scientist. And we have movie rating analysis as well. Okay, TV rating. There are a lot of analysis. This kind of analysis can be done. This is one such simple example how you are going to interpret the problem statement. If this is what your problem statement, you have to do this kind of analysis. For real time, you have to do a model building as well. Yes.